Cambridge IGCSE Chemistry May 2020, Paper 42. Question 1. Part A. Give the name of the process that occurs when a gas turns into a liquid. So when the state of a substance changes from a gas to a liquid, it's condensation. Occurs when a solid turns into a gas without first forming a liquid. So it skips the liquid part and turns straight to gas. It's called sublimation. Is used to separate a mixture of liquids with different boiling points. There's one special method for this. It's called fractional distillation. It uses the fact that they have two different boiling points. Is used to extract aluminum from aluminum oxide. So aluminum requires a special method to be extracted. It's called electrolysis. Is used to separate a mixture of amino acids. Amino acids are colorless and we need another special method which is called the chromatography. Part B. The symbols of the elements in period 2 of the periodic table are shown. For each of the following, give the symbol of an element from period 2 which matches the description. Each element may be used once, more than once, or not at all. Which element combines with hydrogen to produce ammonia? The chemical formula of ammonia is NH3. So what do you need to combine with hydrogen to form NH3? Obviously, it's nitrogen. Makes up approximately 21% of clean, dry air. Yes, you need to know the contents and the percentage of elements in air. For 21%, it's oxygen. Has atoms with only 2 electrons in the outer shell. If it has 2 electrons, it means that it's in group 2. So if you look at the periodic table, these are the elements in group 2, and we were looking at the elements in period 2. So the answer is beryllium. Has atoms with only 7 protons. If it has 7 protons, it means that its proton number is 7. There's only one element with proton number 7, it's nitrogen. Is a monoatomic gas. If it's monoatomic, it means that it's binding with itself only and it doesn't bind with other elements. In order to do that, you have to be very stable. And what elements are stable in the periodic table? Those are the ones that are in group 8. We're looking at period 2 again, so it's neon. Is a soft metal stored in oil? Some metals need to be stored in oil because they are too reactive. And in the periodic table, we often say the group 1 elements are very reactive, so they need to be stored in oil, and the one that is in period 2 is lithium. Question 2. Fluorine forms both ionic and covalent compounds. Part A. Magnesium reacts with fluoride to form the ionic compound magnesium fluoride. The electronic structures of an atom of magnesium and an atom of fluorine are shown. Complete the dot and cross diagram to show the electronic structures of one magnesium ion and one fluoride ion. Show the charges on the ions. If it's an ion, it means that it has already lost or gained some electrons to be stable, while for magnesium, it initially had 2 outer electrons, so you'll have to get rid of both of them to be stable and have only 8 outer electrons. So just draw one more circle around it and plot 8 crosses. Then since it has lost 2 electrons, it will have a positive charge of 2. Then for fluoride ion, it has 7 outer electrons. So instead of losing all 7 of them, it's much easier to gain 1 electron. For this time, you just draw one circle again, then draw 7 dots, and one cross to indicate that this cross actually came from the magnesium ion, but only one of it came because there's only one space left for an extra electron. And since it gained 1 electron, its charge should be -1. What is the formula of magnesium fluoride? Well, magnesium had to lose 2 electrons, so it was Mg2+, and fluoride gained 1 electron, so it's F-. Well, if you form a compound with these 2 ions, you need to balance the charges, so you'll actually need 2 fluoride ions to balance 1 magnesium ion. So you write this as MgF2 to indicate that you need 2 fluoride ions. Magnesium fluoride does not conduct electricity when solid. What can be done to solid magnesium fluoride to make it conduct electricity? They already gave you a hint. It does not conduct electricity because it's solid. In your answer, explain why magnesium fluoride conducts electricity when this change is made. So what's this change? It's very obvious. You make it as a liquid. And how do you do that? You dissolve in water, or you can heat it until it's in the molten state. Then magnesium fluoride will be able to conduct electricity because there will be moving ions if it's in a liquid state. Part B. Carbonyl fluoride COF2 is a covalent compound. The structure of a molecule of COF2 is shown. Complete the dot and cross diagram to show the electron arrangement in a molecule of carbonyl fluoride. Show outer shell electrons only. Okay, this is kind of easy. They have already told you what kind of bonds are here. So these are the single bonds, which means there will be 2 electrons forming a bond together like this. Then there are 2 lines here, which means there is 1 double bond made of 4 electrons. But be careful, this is not the end. We need to fill up the rest of the space. For fluorine atom, it's in group 7, so it initially had 7 outer electrons. Well, now we've only drawn 1 electron from fluoride ion, so we need to draw the rest, which are the 6 electrons. Okay, then for carbon, it's in group 4, so it needs to have 4 outer electrons. While it's already drawn here, it has 4 dots over here, so we don't need to draw anymore. Then for oxygen, it's in group 6, so it needs to have 6 outer electrons, and we've only drawn 2, so let's draw 4 more. Part C. The melting points of magnesium fluoride and carbonyl fluoride are shown. Explain, using your knowledge of structure and bonding, why magnesium fluoride has a high melting point. Well, it was stated in the previous question that magnesium fluoride is an ionic compound. Ionic compounds have a very high melting point because there are forces of attraction between the oppositely charged ions. That's why you need a lot of energy to break the bond. Explain, using your knowledge of structure and bonding, why carbonyl fluoride has a low melting point. This time it's for carbonyl fluoride, and it was mentioned here that it's a covalent compound. So covalent compounds have low melting points because the forces of attraction between the molecules are very weak, so you only need a small amount of energy to break the bond. Question 3, Part A. Sulfuric acid is made from sulfur in a 4-stage process. Stage 1, sulfur is converted into sulfur dioxide, so it's this equation. Stage 2, sulfur dioxide is converted into sulfur trioxide, so it's this. I hope you guys know all these equations. You must know the whole process of manufacture of sulfuric acid. Anyway, Stage 3, sulfur trioxide is converted into oleum. Stage 4, oleum is converted into sulfuric acid. How is sulfur converted into sulfur dioxide in Stage 2? You can see that oxygen is added to it, and it's by heating in air, so sulfur bonds with oxygen in air. Describe how sulfur dioxide is converted into sulfur trioxide in Stage 2. Your answer should include an equation for the reaction, the temperature used, and the name of the catalyst. It's easy, you just have to name 3 things. I've already written the equation here. 2SO2 plus O2 equals 2SO3. Of course, it needs to be balanced. Then the temperature for making sulfur trioxide is 450 degrees. And the name of the catalyst is vanadium 5 oxide. The reaction in Stage 2 can reach equilibrium. What is meant by the term equilibrium? Okay, so even though you don't know a single thing about chemistry, you should still know the definition of equilibrium because it's the most basic thing, and this question is like everywhere. The definition of equilibrium is when the rate of forward reaction and backward reactions are equal and the concentrations of reactants and products are constant. Part B. Sulfur trioxide is converted into oleum H2S2O7 in stage 3. What does sulfur trioxide react with to convert it into oleum? If you write the formula of sulfur trioxide, it's SO3 and it's changed to oleum H2S2O7 by adding something. You can actually figure this out from this equation itself. Well, you need to add H2, so H2, and one more S, then 4 more oxygen atoms. And what is this? It's H2SO4, the sulfuric acid. But they're using this in factories, it's a complicated process, so it needs to be called concentrated sulfuric acid. Part C. Oleum is converted into sulfuric acid in stage 4. They made oleum by adding sulfuric acid, and then now they're converting it back to sulfuric acid again. Interesting process. Write the chemical equation for the conversion of oleum H2S2O7 into sulfuric acid. Well, in this case, you can't really figure this out, you just need to know it. In the last stage of manufacture of sulfuric acid, you need to add H2O to produce sulfuric acid. Make sure your equation is balanced, and yeah, you can see that this whole question is about manufacturing sulfuric acid, so make sure you know the content thoroughly. Part D. When copper is reacted with hot concentrated sulfuric acid, sulfur dioxide gas is formed. Balance the chemical equation for this reaction. A simple question, just balance it. So Cu and Cu, they're just one. Okay, then H2, but you can just guess that there should be something in front of this. We'll move on to sulfur. There's one here, but there are two here. So put a 2 in front to make this 2. And let's see how many oxygen atoms are here. The total number of oxygen atoms on the left side is 8. And on the right side we have 4, 2, and only 1. So you have to make it 2 in front to make this 2. And you'll have 8 oxygen atoms. So everything is balanced. Part E. Sulfur dioxide is a reducing agent. Give the color change that occurs when excess sulfur dioxide is bubbled into acidified aqueous potassium manganate 7. This is also a common reaction. What's the color of potassium manganate 7 before anything has happened to it? It's purple. So the starting color of the solution is purple, and since sulfur dioxide is a reducing agent, it's gonna reduce potassium manganate 7, and the color will change from purple to colorless. Part F. When sulfuric acid reacts with ammonia, the salt is produced and it's called the ammonium sulfate. Write the chemical equation for this reaction. Okay, easy, just change it to chemical formula. Let's write ammonia first because it's ammonium sulfate. NH3 plus H2SO4 gives ammonium sulfate. The charge of ammonium is +1 and the sulfate ion is -2. So if you form a compound, it will be bracket NH4, 2, and SO4. Then you gotta balance this. You can see that there are 2 nitrogen atoms here, so there should be also 2 here. So put a 2 in front. And if you count the number of atoms in each side of the equation, you'll see that it's balanced. Part G. Barium sulfate is an insoluble salt. Barium sulfate can be made from aqueous ammonium sulfate using a precipitation reaction. Name a solution that can be added to aqueous ammonium sulfate to produce a precipitate barium sulfate. So basically, you need to add something to ammonium sulfate to produce barium sulfate. Since we have barium here, obviously the cation of this unknown substance should be barium, and the anion should be more reactive than sulfate in order to displace this guy and take sulfate as its own anion. There are 2 compounds that are more reactive than sulfate and can still form a bond with barium. Those are barium nitrate and barium chloride. You have to write either one of these. Write an ionic equation for this precipitation reaction. Include state symbols. Okay, you have to be careful. They're not asking you to write the ionic equation for the whole process. You just need to write for the precipitation reaction. And the precipitate is barium sulfate. So you just write an ionic equation for barium sulfate only. The ion of barium is Ba2+. It's in an aqueous state, then added with sulfate, SO4 2-, and this is also in an aqueous state, and it gives barium sulfate. And since it's a precipitate, it's in solid. I'll do the rest of the paper in my next video. I hope this video helped you guys to improve your chemistry. Subscribe to get ready for your IGCSE exams. Thank you for watching. Stay safe and God bless you guys. Bye.